Welcome to today's explainer. Look, if you're hanging out with us today, you already know we rely on some pretty complex tech literally every single day. But right now, we're going to do a first principles deep dive into the very foundation of all that tech. We're cutting through the high-level jargon to cleanly deconstruct the digital brain. My goal here is to validate your curiosity, break this architecture down from the ground up, and make sure that by the end of this, you've got a razor-sharp, elegant systems-level understanding of what's actually happening under the hood of your favorite devices. Let's get into it.
Okay, so here's our roadmap for today. First, we'll meet the digital brain, then look at its 6 core superpowers, break down the 5 basic components, and finally, look at how it's powering our world.
All right, part 1, meet the digital brain.
So before we get bogged down in the heavy technical details, I want you to visualize something. Picture a totally tireless, super fast entity just humming along in the background of your life. It doesn't sleep, it definitely doesn't need coffee, and it never complains about being overworked. Which brings us to a fundamental question, right? One that's honestly easy to gloss over because these machines are just everywhere. What exactly is a computer? I mean, we use them to text, stream 4K movies, crunch massive data sets, but if we distill this thing sitting in your pocket down to its absolute core problem-solving nature, how do we actually define it? Well, simply put, a computer is an electronic device that accepts data, processes it based on specific instructions, stores it, and then gives us useful information as output. The really crucial point here is that it turns raw input into highly meaningful output. Think about just typing an email. The raw input, it's just a jumble of random mechanical clicks. You're just mashing down on a piece of plastic. But the computer processes those electrical signals, holds them in its memory, and spits out a beautifully formatted document you can instantly read and send around the globe. It basically takes chaos and organizes it into something you can actually use in the real world. Moving on to part 2, 6 core superpowers. Now that we've got our baseline definition established, we really need to talk about the dynamic capabilities of this machine because they completely blow our own biological limits out of the water. To really get this, let's contrast human traits directly with computer traits. As humans, we get tired. We lose our focus, our attention drifts, we make math errors pretty easily, especially after a grueling day of analytical work. But a computer, it works continuously without an ounce of fatigue whatsoever. Plus, it is completely 100% accurate, assuming the instructions we feed into it are logically sound, of course. And this stark contrast is exactly why computers are so revolutionary. They step in and pick up the slack perfectly right where human biology inevitably leaves off. When we actually list out these specific capabilities, the sheer scope of what this hardware pulls off is insane. We're looking at speed, accuracy, storage, automation, versatility, and reliability. Just think about how this plays out in the real world. Speed means rendering a massive 4K video in minutes instead of hand-drawing frames for a decade. Accuracy ensures a bank crunching millions of compound interest transactions doesn't misplace a single penny. Storage lets us hold the equivalent of a massive multi-story physical library on a piece of silicon no bigger than your fingernail. Automation means a financial trading algorithm just executes trades completely automatically while you're fast asleep. Versatility lets that exact same piece of hardware process a spreadsheet 1 minute and run a highly complex 3D video game the next. And reliability, that guarantees the system will perform these tasks the exact same way, time after time, without its logic ever degrading. But if there is one superpower that truly boggles the mind, it has got to be speed. We are talking about millions upon millions of complex calculations happening in mere seconds. To put that sheer, unadulterated speed into perspective, check this out. The smartphone sitting in your pocket right now processes billions of instructions per second. It is quite literally millions of times more powerful than the massive room-sized computers NASA used to guide the Apollo 11 spacecraft all the way to the moon and back. A math problem that might take a human a lifetime to solve on paper, yeah, this digital brain processes it before you even have a chance to blink. All right, let's slow down a bit for section 3, the 5 basic components. So let's see how this builds into our actual hardware anatomy. We know what it does, but how does it actually do it? Well, there's this beautifully sequential linear journey for a single piece of data, and it happens in 5 core steps. Step 1 is the input unit. Step 2 is the central processing unit or CPU. Step 3 is the memory unit. Step 4 encompasses storage devices, and Step 5 is the output unit. To bring this to life, imagine pressing the send button on a message. That input command travels as an electrical signal straight to the CPU, which acts exactly like the human brain, processing that specific instruction. The data is held temporarily in the memory unit, logged permanently in your storage devices so you can read the sent message tomorrow, and finally, it's confirmed visually on your output unit, which is your screen. And this brilliantly illustrates the real-world hardware examples for each of those steps. Your input unit is your keyboard or mouse, your literal communication bridge to the machine. The CPU processes all that data. It's the true operational center. Now, it is absolutely crucial to understand the difference between these next two elements. The memory unit, like your RAM, acts as your short-term working space. Think of RAM like the top of a physical desk. It's where you put the documents you are actively working on right now for ultra-fast access. But when you turn off the computer, boom, the desk is entirely cleared. Storage devices, on the other hand, like your hard disk or solid-state drive, are your filing cabinets. They save data permanently. It takes slightly longer to retrieve a file from the cabinet than from the top of your desk, but it's kept completely safe for the long haul. And finally, the output unit, your monitor or printer, presents that final processed result right back to you. It is such an elegant, beautifully logical loop.
Which brings us to part 4, powering our world.
Now that we've mapped out the internal hardware and how these distinct pieces actually talk to one another, it's time to zoom back out to the macro level. How do these underlying concepts apply directly to you and modern society? The sheer diversity of industries powered by computers is just staggering. Education, banking, healthcare, business, communication, entertainment, and scientific research. Every single one of these global pillars has been completely revolutionized by those 5 simple hardware components we just dissected. Take healthcare and scientific research, for example. The mapping of the human genome, a massive feat that decoded our very DNA and revolutionized modern medicine, was entirely dependent on massive data processing capabilities. Without the digital brain, analyzing those billions of genetic base pairs, it would have been physically impossible. At their core, computers are the ultimate problem solver. They allow us to work faster, save massive amounts of our precious time, and solve wildly complex problems with unprecedented efficiency. It is honestly fascinating to think about the historical context here. In a remarkably short amount of time, we have transitioned from relying on clunky, room-sized novelties in the mid-20th century, machines that took a massive team of engineers just to swap out a single burning vacuum tube, to having an absolutely vital, indispensable cornerstone of human civilization baked into everything, from our pocket-sized communication devices to the cars we drive every single day. So, that leaves us with a final provocative thought to chew on. The digital brain is sitting there endlessly capable, just waiting for your input. What problem will you solve next? Because as a focused learner, you now truly understand the foundational essentials. From the precise flow of input to output, to that critical difference between memory and storage, and the sheer computational speed of the processor tying it all together. You literally hold the conceptual keys to maximizing this incredible tool. Thank you so much for joining me for this explainer. Keep expanding your knowledge, keep asking those deep structural questions, and I'll catch you next time.